Alright, let's look at some salts, and in particular, let's look at the difference between acidic salts, basic salts, and neutral salts. We're kind of going to stay away from oxides at this point, and we'll look at those in a different video a little bit down the road. So, what is an acidic salt? Basically, these are salts that when you dissolve them in water, you get a pH of less than 7. That's pretty straightforward. Like, there's no groundbreaking stuff there. But how do we get them? Well, they're formed between when you have a reaction between a strong acid and a weak base. Okay, so we'll give you an example. Ammonium chloride comes from the addition of hydrochloric acid, a strong acid, and ammonia, a weak base. And it gives you ammonium chloride. Okay, so what that looks like in the end is you have ammonium or chloride, which when you dilute it, so when you disassociate that again, you get an ammonium ion. And when an ammonium ion is in water, it's going to act as an acid. So for example, here it's ammonium, and it has an extra proton here. It gives one of these protons over here, so you get an H over here, it comes over this way there. And that gives you NH3. Now that's not a negative ion, but it is less positive, is more negative than it was before. So this has donated a proton, and it's become more negative. And that makes it an acid, which means this over here, so this is our acid, this will be our conjugate base. That means the water in this case is a base, and over here, it's a conjugate acid. So let's have a look at a basic salt. Basically, basic salts are when you dissolve them in water, you will get a pH of higher than 7, or greater than 7. And they're formed from kind of the opposite reaction. So when you get a strong base and a weak acid, you're going to get a basic salt. So sodium acetate is a good example of a basic salt, actually. And we get that from putting acetic acid with sodium hydroxide, which is our strong base. Acetic acid is a weakly ionizing, partially ionizing acid. So here's our acetic acid, and we combine it with our sodium hydroxide, and this gives us water plus sodium acetate. And that's cool. Now let's have a look at what happens when we get sodium acetate. Now, this will be a weak base, and it will be a weak base because it will produce hydroxide ions. So let's have a look how that works. So you've got the sodium acetate, which in this case, the acetate ion combines with water, and it strips one of the protons off there. So in this case, this is a base, and the water, which donates a proton to make that actually makes acetic acid. So it donates a proton over here to the acetate ion, making this one here the acid. Okay, which means this is the conjugate base, and the conjugate acid, and this one here is the conjugate base. And that makes perfect sense that this would be a conjugate acid, because if the reaction was reversed, this is acetic acid, right, which would be giving a hydrogen to the water, to the hydroxide. So in this case, though, because the reaction is going forward, we have an acetate ion, because it separates from the sodium, an acetate ion reacting with water to take a proton. Okay, so the water here becomes a negative ion, and it donates a proton, which means the water is acting as an acid. This accepts a proton and becomes more positive, which means it's the base. Now, if you want to look at a neutral salt, these are ones that when you dissolve them in water, the pH is equal to or very close to 7. So basically, when we neutralize a strong acid and a strong base, we will get a neutral salt. Now, if you do a weak acid and a weak base, it's also the same, but you've kind of got to get it right. So basically, strong acid, strong base will get a neutral salt. Weak acid, weak base will also get you a neutral salt. So sodium chloride is a perfect example of this. When you dissolve sodium chloride, which goes from mixing hydrochloric acid and sodium hydroxide together, both strong acids, when you put sodium chloride in the water, though, it does not react further. It just disassociates. So this one here, if we were to put that in water, all we would get would be NaCl goes to, and it would dissociate completely, an Na plus ion and Cl minus ion. That's all you would get. I hope that made sense. If you have any questions, feel free to ask them in the comments below. We actually monitor those pretty closely. We'll get back to you as quick as we can. And yeah, thanks for watching. See you next time. Bye now.